I would like to present for you now Paul Schulz, who will be giving us a talk on Free Your Mind and Your Devices Will Follow using ESPHome. Please welcome Paul.
Thank you very much. So the typo in the said free you mind and meant free your mind, but the point is that this is an introductory topic, introductory session on ESPHome. It might just get a quick show of hands. Who has used ESPHome themselves? A few people. Arduino, who's written an Arduino sketch? A few more people. Anyone not used any embedded? Excellent. Just get a bit of a feel. We read the welcome, so thank you very much, Soz. The table of contents, I'll be going through stuff, sort of what it is. I've got some examples of hardware. There's some there's some demonstrations. Hopefully the demonstration guides will be good to us, and we'll show you some things. I wasn't expecting the high stage. Feel free to come up to me afterwards, and I can show you some more of the things that I've got. But I'll just be going through an introduction. In terms of motivation, why ESPHome? I've got a brief video from Lewis Rossman about appliances and how they're being sold to us. So we'll see if this
with any device that uses closed source software that requires a connection to the internet in order to work is that means that the manufacturer can take back the features and functionality of the device at any point in time. Further, it means that the manufacturer can change the terms of the sale. As long as the device needs to connect to the manufacturer's servers in order to work, and as long as it has the ability to do that without you taking it away, the manufacturer can change the terms of the sale and they can change the conditions under which the device will work. For instance,
okay, and then he goes on. So if you want to watch that video, language warning, I got permission from him to use that, but that's, in a nutshell, what the problem is. If we buy appliances, a lot of people like hacking and doing their own work, but if you're buying something, look for the ESPHome logo. It's one of the ways in which we can maintain our freedom, because it actually allows you to update the firmware and modify things if you want and have control yourself. And it's also a way of supporting open source companies. ESPHome is a sister project of Home Assistant, for those people that know about Home Assistant, and that's supported with Nabu Casa company. Athom, and I'll talk about these are the manufacturers of the products I'm going to display. M5 Stack and Heltec Automation make a development chip. So the purpose of the talk is just to show you one way in which we can maintain our freedom and and those freedoms in the devices and things that we use around the home. A bit busy, this one, but that's just a layout of some of the way I had connected things up. I've got a Raspberry Pi at the top running Home Assistant. If you're interested about that, you can talk to me. You can talk to me about that as well, but I'm not going to be going to that in detail. It's well worth checking out. And the various devices are talking to Wi-Fi to the Raspberry Pi that's running that up here. And then all the files and things are on the GitHub repository down the bottom there. So if you want access to any of this, it's there. Go look it up. But I'm more than happy to catch up with me during the conference or online, or give you details. So ESPHome, as I mentioned, was a sister project to Home Assistant. The other programming environments that are in the same space are listed there: Arduino, Platform.io, MicroPython, Tasmota, and I'm assuming there are a few others. It's a way of producing the firmware that you put onto a microcontroller to do stuff. Arduino was the first one with for hobbyists that came out. And I believe there was another talk this morning about an audio project where he rolled his own. So they're everywhere. It was originally written for the ESP3266 there, and now the ESP32s, which are the next version of these chips. What is ESPHome? Some of the characteristics. It's written in Python. The programs are described in a YAML file, so it's all declaration sort of based. If you want to get into the C and Arduino type programming, you can, and I'll show some examples at the end. It has a whole bunch of components, and you pick and choose the components you want to build the system that you want. So it's quite versatile, and you can write your own components to include them. The YAML declarations, the Python looks at those and converts that into C and C++ code, which is then processed through to produce the firmware. What are the benefits? You can put your YAML into a configuration management control. Everything's versioned. It's all text-based. The formats, like, it's well-defined, easy to understand and modify and control. So it's and it's designed to be actually accessible over the internet in the world, in the sense that a manufacturer will publish the YAML for their particular device and make it available on GitHub, and the device will be able to publish that when you access it, so you know where you can get the code straight off the network. The devices that I've got here are a range. The first one, Smart Switch. This is this Athom Smart Switch. It's running ESP, the older version, and it's like the Australian standard. They come in ESPHome as well as Tasmota, and they're readily available and cheap. You can plug them in, and they, as well as doing relay for switching appliances on and off remotely, it's also got a power meter in there, so you can actually measure how much your kettle is using, when your kettle's on, things like that. The second one on there is this little M5 stack. It's got a microphone and a speaker, and the Home Assistant people are starting to use this for like the wake word for controlling automations and things around the home. So that's another piece. And then finally, if you want to do your own development, there are development boards. And here's one that I was working on for another project, and I can demonstrate that one at the end. So that's kind of the range. There's the prepackaged ones, like the Smart Switch has no serial input. It's only accessed over Wi-Fi. There is a factory reset on it, but you can't open it up and look at it. I've got one here that I've broken open, so you can, but it's designed to be a sealed unit, no serviceable parts inside. The M5 stack Atom Echo is designed to be used as a little micro that you can use to program other stuff, and the development board is, if you break it, you get to keep both bits. Okay, so how can I install and use ESPHome? There are a couple of methods they recommend on the website. The easiest one to use is through Home Assistant. If you install Home Assistant on a Raspberry Pi, there's a plug-in for it, an add-on that will put ESPHome, the programming environment, and let you use that. So in terms of what you see, there's a dashboard. You can see that I'll go through some more details, but that's the YAML file that comes with that Smart Switch. The core of it sort of starts from the ESPHome. I hope might be a bit too small, but and that comes from the website, and you can install that. There's an option for install, validate, etc. So, for instance, if you have one of these and you're putting it in an area where you don't want someone to come in and use the button, you can comment out the line of the code that actually says what the button on the side of it does, or make it do something else. So it's customizable. The second way of installing is as a native Python application. There are a few issues there because it relies on the version of Python you've got. And there's been some Python migration, so I won't talk too much about that one. And the last step is actually just downloading it directly through GitHub and installing and running it in a venv environment. So I might actually just do that. Stop the video. So again, ESPHome. Sorry. So those were the Home Assistant add-ons that I was using. But yeah, so download and install, use your git clone, cd, run a setup script, source the virtual environment, and then you can create a working directory and you just run that command at the bottom, which produces exactly the same as that dashboard that we saw in Home Assistant, which looks like that. Excuse me for a sec. So here I've got a bunch of YAML files. The Athom Smart Switch is what we saw in that in the dashboard. And if we scroll down, for instance, we'll see a whole lot of definitions. If people aren't familiar with YAML, yet another markup language, or YAML is not a markup language. Anyway, it's a fixed, indented, formatted file structure that gives you lists and dictionaries or named keyed data structures, which you can kind of just see there. So, for instance, we've defined something in a sensor. There's a particular component called uptime, and it just takes these values here to set it up. So that's pretty much all there is to configure what the code that you want to actually put on the device. If you, I might just go back to the presentation. Yeah. So I showed the ESPHome on Home Assistant. That gave you that dashboard. If you're starting from scratch, you've got a brand new device. It might be like the M5 stamp. There's a built-in wizard to ESPHome. So we go ESPHome, wizard, demo. How about we put some spaces in? YAML, a little bit chatty. And so this will go and build a YAML file for you. I'll call it demo. What board do we want? Well, we're using a ESP32. So what processor? Now there's a whole bunch of boards. We're going to use the M5 stack. What did Athom. And I won't put details in, but here at this point you can put your Wi-Fi account and password. I'll try again. something, and it now creates, well, after set for the OTA, so over the air, once it's connected to a Wi-Fi, then you can actually install it and upgrade it over the Wi-Fi as well. So you don't need to connect a serial port anymore. If we have a look at that, demo.yaml file, it's put the name at the top, it's declared an ESP32 board with the board name, the framework you can use, that uses Arduino as its structure in one case, or there's also the platform IO format as well. And then it puts passwords and configures those. And then some other options as well. But that's the basics, and then you can then add to that YAML file the components that you may want to add. And the source of information for that is the ESPHome website, and they list anything that you might need. So if you've got for instance, we've got an air quality sensor you want to connect to it, pick one, and that just describes what you need in your YAML. So this is the IKEA one. If you want to connect to it via the USB port, or this guy's got a pin, got a straight connection to a pin. They describe some things about that particular sensor. You would put that in the YAML file, and then when you compile your YAML, or run your YAML, it will compile it up for you. So there's some other examples of some things that you could use. The web server component will actually put a little web server on there as well and show you the sensors that you're reporting and allow you to control them as well. But the sort of the main power then comes in allowing your sensors to then connect to something like Home Assistant, which means it allows you to use it to trigger other events or use other events to set things happening on your device. We may come back to that. So yeah, so examples like there's a binary sensor there, which configures a button. The light there does an RGB light, which you can, NeoPixels, so you can run that. Why is this useful for developers? You've got everything in a single text file, like everything's separated out. It is using Arduino sort of under the hood, but they've extrapolated it in the sense that you can support multiple devices. I'm no longer dealing with a single loop function. That's sort of taken away, and I can now add multiple features, take features in, put features in, take features out, sort of as I need them to test and try and if something's giving me an issue, I can get rid of everything else and just look at one particular part. A lot of the components are on GitHub, so there's a lot of code reuse. It's easy to distribute changes. If there's a particular sensor that you're interested in, more than likely someone's already written a component for it. Yeah, so some of the other things you can do, sort of, you can like get it. You can, and I won't talk about all of these, but there are ways to set up persistent data. So on reboot, you get the same data that is stored there, and it's straightforward to do. If you're working with an Arduino script and suddenly you have to worry about bringing in something else and timeouts and waiting for events, this takes care of all of that sort of OS-y type stuff that you might be used to. It integrates with Home Assistant and, again, like the web server component. If you were building something like this for a customer, you might actually compile in some CSS files as well to make the website a little bit prettier. For those of people that have played with Arduino, I might just quickly go through what would you do if you had an Arduino sketch and you wanted to use ESPHome. You need to pretty much port everything over to more C++ type environment. The blue stuff on the blue text there is, you take the existing Arduino sketch, add some packing around it. It's reasonably straightforward, but it's not particularly well documented. So that's sort of why I've included it in the talk. Once you've done that, you create a Python declaration file, which kind of says how to wrap that into the rest of it. So you've got the namespace and the class that you need to define. The Python knows about that. And then it allows you to set up configuration flows and some instruction on how to convert this, the YAML into code that can be used. So again, this is not what you'd normally have to do. This is just for if you've got some existing Arduino code and you want to pull it into a component that you can then use like all the other components. And finally, the point is that you can then use your component in your YAML. And if you need additional libraries, you can pull those in too. So your final component would have those files there listed. Just as an example. Okay, where could you find documentation and support? Website's pretty good. There's some excellent community support in the ESPHome. And then getting started for the browser-based stuff. There's actually a web-based GUI as well for writing these devices out. And I mentioned the Home Assistant add-on, which produces that dashboard. That one there. So what I might do is kick off how are we going? Yep. So I'm happy to take questions. I think there should be heaps of time left. But in the meantime, I might just kick off a compile so you can see what it actually does. What I've got. So, from another project I was doing, we actually built we were building a muon detector and had an ESPHome in it. You can talk to me about that as well if you're interested. But to install and run, it's just ESPHome run and the YAML file. The ESPHome software will go through and find all the dependencies. It's reporting on what the board is and what the platform is that's using. It's looking up all its dependencies and downloading them. And with any luck, it'll go off and compile. So while it does that, are there any questions? Sort of screaming along for time. I will choose serial, so it gives you the option of how you want to program it.
So I have a kind of very specific question here. I picked up a little board with an ESP32 and an e-ink display, and I think I know what chip it's based on, but as far as I can see, it's not supported in ESPHome yet. So I'm kind of interested, what steps do I need to go through to get that added to the ESPHome?
What's the board? It's from an ESP32?
It's an ESP32 board.
Right.
Sorry, no, it's a Raspberry Pi 2040W board, and the display is based on a UC8151. So I can. That's as much as I know so far.
Yeah, okay, so these Heltec boards, weren't in that list. that I showed when I was running the wizard. But you can say explicitly in your YAML, this is the processor that I've got, and you have to pick a dev board that's sort of the closest to what you've got, and specify the processor, and it will still work. It will complain a bit because one of the things that it likes doing is checking that if you define a particular pin, if it knows what board you're using, it'll try to tell you whether that's a useful pin or not, or if it's used for something else. So you quite often get warnings about, hey, these pins are used by this board for external RAM, for instance. So that's an example. But you can usually fudge it to make it work for your board, because they're just warnings. But sometimes until a new ESP version, well, not even much of an ESPHome version comes out, because it's relying on Platform IO, and Platform IO is the thing that has all the board definitions in it. So if you check Platform IO to see if your board is in that list, then eventually you'll get it, kind of thing.
Thanks for the talk. So I have noticed that all talks are concentrating on Home Assistant, and it sounds Home Assistant centric, which I really dislike, as I find Home Assistant OSS, but not FOSS, compared to domotics. Most of the plugins for Home Assistant are costly, like remotes, dashboards, skins, and stuff. There's a hidden cost behind the Home Assistant versus domotics that doesn't incur nearly as much cost for the high-end customization. So is it compatible with domotics? And if not, is it going to be, or is it, can it talk to MQTT at least? Because that will solve the...
So the way I've got it at the moment is I'm just using Home Assistant as that dashboard, but Home Assistant knows enough about ESP in that it will automatically, like there's an API in ESPHome that Home Assistant understands. So it will pull in all your stuff into Home Assistant. Now, it's open source, so if you want to find out what that API is, you probably could. It's not, it's not particularly well published or documented, but at the same time, you can, like with this unit here, I've got it sending UDP packets because that's what we needed. So you're not restricted to using Home Assistant. Does that answer your question? Sorry. Sorry? Yeah. It certainly does do MQTT. Which certainly should. Yeah. Thank you. There are things like with MQTT, like birth and death messages, so that Home Assistant knows about how the device is working. But if you've got access to if you set it to access to an MQTT server, then certainly it'll quite happily work with whatever you're using. Any other? Yes, Vic.
Hi, I have the talking stick. Are there any particular sort of home environments or conditions that mean you shouldn't actually be using home automation systems like this?
What have you got something specific in mind?
Oh well, I've done home automation, and I was using a system called X10 many years ago, and then compact fluorescent lights came along and totally killed X10 because data couldn't be transmitted during the main zero crossing, and that totally ruined my house, which I had built specially to run on X10. So I was wondering what sort of caveats there might be about using home automation systems that could sort of leap up and bite you if you aren't careful.
I haven't been playing in the space long enough, I never did get the X10. The next step that like home automation is going to be Matter and what's the Matter and Thread, which is the Google and the Amazon like product that they're pushing. So Matter is the like the MQTT type action, and Thread is the networking layer. At the moment, the Home Assistant people that are working with ESPHome don't have a way of, if you've got an ESPHome device that supports Matter and Thread, which they're working on, you can't. There is no. They haven't got their own setup app. You have to use the Google or the Apple one to put it onto your Thread network. And once you've done that, then you can put it onto your own partition of that sort of thing, just because of the key exchange and the way they're working. But you can get, if you're getting Thread and Matter devices, which they're starting to appear on the market, you can suck them away from your proprietary Google and Amazon setups into your own controlled network. One of the things that Home Assistant are keen on, and it wasn't meant to be a Home Assistant talk, was allowing you your own Wi-Fi control. Creating devices that and a system that doesn't rely on the internet to work. The Optus outages and whatever, like people on the radio were ringing up saying that, like, my internet's down and now I can't turn on my garden lights, for instance. This is putting control back into your hands and the freedom to work with your own appliances in your own way. Yes?
Hey, thanks for the session. I use a couple of lightweight nodes to do BTLE data tracking and capture with ESPHome, and it works really nicely. It's really nice and simple. But looking at that ecosystem, how are you seeing in terms of kind of off-the-shelf device reliability? Having a lot of smart plugs just die, overheat. What's your experience with the Athom plugs and
I've had one, and I've got it here that just stopped working. I don't know why. I haven't poked at it. I've sort of broken open to have a bit of a look. I'm a bit loath to pass it around because it's open and we've got PowerPoints and all the... Anyway, generally, but other than that, fine. So having a spare around isn't such a bad idea, but...
Is it still on? It looks like there was a whole batch of the 8266s just seemed to burn out quite quickly.
Yeah.
On the and then Toya, who were basically the base hardware for a lot of devices you could hack, have changed their chips dramatically, and they're actually less reliable, but you can't hack them now.
Right.
So you really got, if you're looking at putting this on an off-the-shelf device that's already running a proprietary firmware, it's getting a hell of a lot harder now. But it's a pretty vibrant ecosystem. Where's the code you were showing? You said there's, when you produced that demo code,
Yep.
it was using the Arduino framework. Why would you choose between the two different kind of framework options?
Arduino was the first one, and it actually then ends up using Platform IO. But it's just the way that it's the intermediary step of the code. Like it gets written out into an Arduino format with setup and loop functions, and then that gets compiled into the firmware. When you pick the IDF or the Platform IO version directly, it sort of skips that, and that's where they're aiming to go. But I don't know all the details, but apparently there's some components that people have written that depend on one or the other. And at the end of the day, they want to go directly to Platform IO rather than the Arduino to remove that dependency. But it's sort of not really a dependency because it's there anyway. They're not actually using Arduino as such, they're using the format of the files. Is that all right? Does that?
Okay, do we have any more questions?
If I go back, so we'll go back. So just special offer. I got sent some Athom Smart plugs. So I've got 3 to give away. And I think I was giving away to some of the questions. So I think you got one. Vic, if you can have one, and there was someone else. Who else asked the question? You put either or. So I've got them up here. And also, if you order a smart plug from the Athom store, you can get 10% off with the EO 2024 code. And finally, I might just... I'll do that. It's a bit more impressive if I string it out, but that's running the ESPHome code that we just compiled and installed then. And you can see it triggering, like every time I trigger it, it'll adds a count and just produces that pattern. Anyway, so thank you very much.
Thank you, Paul.